All right, welcome back to Dilemma's Concepts. So what we're looking at today is triangle congruence. So we're going to be looking at four postulates right now that will help us to decide when triangles are congruent. So on screen, what we have is triangle ABC and triangle LMN, right? So let us say that we are given ideas, for example, that this side AB is congruent to LM. Also, we learned that the angle at A is congruent to the angle at L. And side AC is congruent to the side LN. As you could see, when you take a look at this, we're looking at a side angle side, right? So we're seeing a side and an angle and a side. So this postulate is called the SAS postulate, one in which we were able to relate two triangles that would have a side and an angle and a side in that same order that are actually congruent. So then we can conclude that triangle A, B, C is congruent to triangle L, M, N. And I want us to take note of the order in which the vertices of the triangles were named A, B, C, in that order, L, M, N, right? All right, so that's one, where we look at side, angle, and another side. All right. All right, let's take a look at this second one here, right? So in this one, we have P, Q, we have PQR and VXY. So PQR and VSY. Let's take a quick look at this. Now, so let's say we're given that this angle at P here is actually congruent to this angle at V. Also, we do realize that this side PQ is congruent to VX, and the angle at Q is congruent to the angle at X. So if we take a look, we're seeing here where we have an angle, a side, and an angle that is congruent to another triangle's same angle at V, side VX, and another angle at X. So in this one, if you notice, we have angle, side, angle. So this postulate, right, is the ASA. And we're talking about angle, side, angle postulate. That this triangle P, Q, R is congruent to the triangle V, X, Y. Please note again the corresponding parts of each. P correspond with V, Q correspond with X, and R correspond with Y. So in that breath, you can know that PR is the same as VY and PQ is the same as VX, all right? So we want to make note of those ideas. All right, let's take a look at another one, right? Let's take a look at another idea. Now, let us say that we find ourselves with this. And then in this case, we're seeing where we have two triangles, DEF and PQR. So let us say DE is congruent to PQ and EF is congruent to QR. Also, if we realize that DF is congruent to PR, we will be noticing that we do have three sides of triangle DEF that corresponds with the three sides of triangle PQR. We would notice that we have a side that is congruent to aside from the other triangle, and a side and a side. So in this case, we're looking at side, side, side postulate. So in this case, I could say that the triangle FDE is congruent to triangle RPQ. So I got a flow. If I go FDE, based on the context of these two triangles, I have to go RPQ. All right. So we have to look at the corresponding parts when we're naming them. So in this postulate, we have three sides that are actually congruent. Let's look at another one. So in this one, I have triangle XYZ and triangle ABC. So let's take a quick look. So let us say I have this angle here that corresponds with this angle here. It's congruent, should say. And this angle at Z is congruent to the angle at C. Finally, we realize that this side XZ is congruent to AC. Now, if we take a look, we're noticing that we have here, we have an angle Y that is congruent to angle B from the other triangle, and then angle Z is congruent to angle C, and then the side XZ is congruent to the side AC. Then from this, we could conclude that the triangle XYZ is congruent to the triangle ABC by angle, angle, side postulate. So we're talking about angle, 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 side postulate. So these four postulates here can actually help us to show or to prove when two triangles are congruent. So in conclusion, here they are. We have a side, side, side postulate. We have a side, angle, side postulate. We have an angle, side, angle postulate. And lastly, we have a angle, angle, side postulate. In the next video, I'm going to be looking at the hypotenuse leg, right? Where we're going to use the HL postulate. And this HL stands for the hypotenuse leg of a right angle triangle. Stay tuned to Daniel's concept and see you next time.